new chapters on crystallization. Alright, so the crystallization is also not a very tough chapter. Okay, it's quite simple, similar like the adsorption. Okay, so in general, in crystallization, there have two things that you need to know. Okay, so there are two things that you need to know about the calculation. This is about related to problem solving. One is on, to summarize, one is about the mass energy balance. Okay, this one is back to the mass MEB when you took it during your second year or first year. I can't remember. It depends. If you direct entry, maybe first year. If you are from maybe not diploma, maybe STPM, maybe MEB going to be your second year, maybe. All right. So first is about the MEB. You need to do mass balance and energy balance of the crystallizer. Okay, in crystallization, the unit we call it crystallizer. Okay, and the second part, okay, they have two things. The important calculation is we want to know the growth of crystal or crystal growth. Okay, we want to know. So this crystal, what is the growth rate? Okay, is the length is growth for depending on time. For example, 1 centimeter per hour, 1 centimeter per day. So we want to know that. Okay, we want to calculate it. Okay, the crystal growth rate, the size. Okay, the prediction of size that could be. Okay, size prediction. The size prediction can be like the mean size, can be the larger size, can be the average of them. 50% is containing what size? All right. And then what else? The nucleation rate. Okay, nucleation rate. We call it nucleation. What is nucleation rate? Before it's become bigger crystal. Okay, let's say this is your crystal. It's become bigger. So normally this crystal start from small size of what we call it nuclei. Okay, from nuclei, it start to grow, become bigger and bigger and bigger. So the size is growing. Look at that crystal. So the second part is focusing on that. And then the first part is, I think it's rather easy for you because it's mass and energy balance, right? So because most of you score A, I think, A or B for mass energy balance. So it's easy for you to do calculation for crystallization. All right, so the crystallization is basically a separation whereby you want to separate between solid and liquid. Okay, so the solid in the form of crystal, the liquid is basically the liquid that containing that solid crystal. Okay, in which mass transfer of a solid from liquid solution to a pure solid crystalline phase occurs. So in this particular case, normally before it turn to become crystal, so what happened? So this is your liquid or your solution or your slurry, not slurry because it's normally is a liquid form. So this liquid form, because in that liquid you have solute. Okay, so this you have solute there, but that solute is basically soluble. Okay, not yet become crystal. It's still in soluble form. So you want to force it. Okay, that's because that solute has a tendency to become crystal, to become solid by manipulating certain operating parameters. Okay, let's say you cool down or you heating up or you put some pressure, so then it can force the solute to become solid in the form of crystal. Okay, so when it becomes crystal with some operation force or some other thermodynamic factors. So now the solid, the liquid that you have, this solid in terms of ion, for example, is still soluble. So now you will get liquid and also your solid. So this is still in your liquid. So this is now solid in terms of crystal. Okay, now you want to separate it. So this is the principle of crystallization. It's not really you already have a crystal in your liquid, so meaning that you already have your liquid and solid, and then you want to separate it. No. Okay, that one is normally you're going to use like mechanical physical separation. Yeah, to last chapter 5. Alright. But now you have in a liquid, you have liquid form, so that you have solute that can become thermodynamically later on. If you change something, it can become solid, crystal. So then you want to separate it. Alright. So how they can occurs? For example, the freezing of water from ice. Simple example, freezing of water from ice. Okay, you ada water, you masuk dalam freezer, tu dia jadi ice. Itu sebenarnya dalam bentuk apa? Crystal. Okay, ice to crystal. Kalau you tengok under microscope, you can see the structure of that crystal. Okay, or the formation. Ni paling simple lah, nak tahu. You want to know the phenomena, how this crystal formation occur. So the formation of snow particle from a vapor. So this one normally bila in the four season country where they have the winter. So you see that sebenarnya the snow is basically coming from the vapor, or it's like a raining. Okay, sebenarnya dia nak raining, but because of the dew point, the temperature there is having tendency from that liquid of raining turn to become crystal, to become ice or snow. So dia jadi snow lah. Okay, sebenarnya snow ni berlaku because of it's raining. That day is basically raining, but because the temperature and the dew point, they reach a certain dew point. Dew point meaning is that the temperature of that liquid can condense and become solid. So then dia pun jadi turn into snow, right? And then the formation of solid particle from liquid melt. So some liquid melt because of the concentration is high, and then it tend to become solid particle. So that solid particle, normally we call it as a crystal. The formation of solid crystal from liquid solution. Ni liquid melt ni concentrated lah. Liquid solution ni yang little bit less concentrated. Okay, commercial application. Contoh, example, production of sugar, MSG, sodium hydroxide, okay, home salt. So contoh sugar lah paling mudah. Sugar beets that you use at home, okay, when you want to prepare some drinks, so you put some sugar, so that sugar is basically in crystal form. Or even the salt, okay, salt yang you use for cooking is also crystal form. So macam ni dia buat, basically at the beginning it's a liquid, and then they force it to become a crystal, and then they separate the crystal and also the liquid, and then they do the packaging and so on. Alright, when we talk about the crystal, normally crystallization we talk about the yield and purity. Okay, yield means that how much that you can recover from that liquid. For example, from 1 liters of liquid, how much that you can get crystal, 500 gram, 200 gram, so that is the yield. And purity, so purity meaning that the crystal that you obtain is 99.9% high purity, or is 80% only, some contamination in it. It depends. Size and shape, okay, so they have a different size and shape, whether uniform or not. Okay, and then this one size and shape basically to avoid caking, and then it's easy for pouring, easy in washing and filtering. So why they have a certain shape and size? So this is to facilitate this activity. Okay, if you have any question, you can just ask me. Okay, no problem. You can interrupt me. Okay, type of crystal. This one I think most of you already know. Even if you're gonna learn detail about the structure of material, it's the same. Okay, in the material science subject, something like that, related to material. So the shape, the geometry is going to be like cubical, tetragonal, orthorhombic, hexagonal, monoclinic, triclinic, trigonal. So this is 7 class of crystal structure geometry. It's the same like the material engineering punya subjek, you akan belajar benda yang sama lah. Kalau kata dia dalam bentuk cubicle, so this is like cubicle. Alright, so it depends pada dia punya geometry shape. And this is like, it's also crystal that form in the cave, for example, stalagmite, stalactite, okay? So that are naturally formed. Alright, so you see that the colors, so you can reflection from the crystal. And this is the crystal shape, for example, normally kalau dalam snow lah. Snow tu normally they will draw the flake of snow is something like this. Okay, the shape. Soalan ke? Alright, equipment for crystallization. So it depends on the method to bring super saturation. Okay, dia ada relation dengan super saturation. Okay, this one, how I want to explain. Okay, I will explain that first before I move on to this the equipment. Okay, super saturation and so on. Okay, the crystallization is basically depending on the solubility. Okay, if you know what is solubility, then it's going to be good. Okay, solubility is basically, let's say you are the beaker. Okay, you fill up that beaker with 1 liter of water lah, and then you pour sugar. Okay, let's say you pour sugar bit by bit, and then you agitate it. Alright, you know that in 1 liter, sugar can dissolve, like say, they have a maximum limit, right? Solubility. So solubility means that berapa banyak, how much mass, okay, ataupun gram of sugar can dissolve in 1 liter of water. Let's say in 1 liter maybe sugar ni boleh dissolve let's say 400 gram je. So 500 gram per liter of sugar per 1 liter of water. So that is normally the unit of solubility for sugar. But if you put more, let's say you exceeding 500 gram, because 1 liter only 500 gram can dissolve in 1 liter of water. But what if you put more? Let's say you put 600. What happened to that 100 gram? Can someone answer me? Help me to answer this. Let's say you put more. You know that solubility is 500 gram only for 1 liter, but you put 600. What happened to that 100?
Cannot dissolve and then form crystal in the water.
Yes, that is right. So meaning that, let's say this is your 500. You just imagine when you put it 500, because the solubility unit is 500, so this is 500 gram. So 500 gram already occupied all the space that you have in the liquid. So now you put more, 600, so you have excess of 100. So what happened to that 100? 100 will still in the crystal form. So meaning that they already reach what? What we call it saturation. Okay, that 500 is already reached at saturation. But when you put more, you are at the super saturation. Kita nak super. Okay, you have to bring the condition until you reach super saturation. You don't want not super, just normal. Normal saturation, no. Normal saturation is going to be like will dissolve, not dissolve. Dissolve, not dissolve. A little bit of like a transition period. But to confirm that you're going to have crystal, you need to work to bring the solution at the super saturation condition. Faham? Might be super, like Superman, Superwoman, super whatever lah. Any super, alright? Super duper. So, bila dah super, barulah confirm you akan dapat crystal. So, how to bring that super saturation? So, sebab because it depends pada solubility. But you know that this solubility, dia ada interaction dengan factor of temperature. Okay? Let's say this is 500, maybe at temperature, room temperature, maybe 25 degrees Celsius. But if you increase the temperature, the stability will be increasing. So more sugar can dissolve in 1 liter, because if you have more you increase the temperature, the stability will become larger, right? But now we fix the temperature like 25. So if you put more, so you're going to reach the super saturation. So how to get that super saturation? So you can do that by cooling. Cooling the solution with negligible evaporation. Maknanya there's no evaporation when you do cooling. So why you can do cooling to get that super saturation? Okay, remember, as you increase temperature, stability akan increase. But what happen if you decrease the temperature? Stability pun akan decrease. Meaning that kalau 25 ni, you be able to dissolve 500 gram, but at maybe 10 degrees Celsius, you only be able to dissolve maybe 100 gram je. So 100 gram, let's say you operate at temperature at 10 degrees Celsius and the stability is 100 gram and you put it the same, 600 gram. So what happened? You're going to have like 500 gram going to be in the crystal form, right? Compared to this one, 25, you have 500 gram stability and you put 600. Only 100 yang akan form crystal, yang akan stay dalam crystal, right? Tapi kalau you reduce temperature, you dah ada 500. So you get more crystal. Okay, still in the crystal form. So this is the terminology, how. Or you can confirm it through a very simple experiment. Simple je, you kat rumah you boleh buat. Yang ni mungkin boleh masuk dalam lab punya sheet lah kot later on. Boleh buat kalau ada yang lab. So, katalah you nak buat air, you pakai cold water, you pakai hot water. You can see the difference tak bila you letak sugar? Ada tak beza dia?
Ada.
Ada. Apa beza dia?
Tak larut.
Tak larut.
Ketak gula larut.
Tak. Dia larut tapi dia akan ambil masa yang lama untuk you dissolve. Mungkin ada setengah air tak larut pun. Susah nak larut, right? So because of the temperature tu main peranan, solubility. So maknanya because apa dia tak larut, they not dissolve because the solubility is already there. They are reaching that solubility punya value. So you have more, so that one is not dissolving. Alright, so we want to bring that. So normally in crystallization ni, sebab tu kalau you tengok setting of crystallization normally dia ada cooling. Dia ada cooling. Ada juga cara lain. Okay, but this one you just read through because it's a tank or batch crystallizer. This is normal lah. Mana-mana you ada operation pun, not only crystallization, tank or batch. Okay, you need to know the stability curve. Decrease markedly with temperature. Ni saya cakap lah. And yang penting, importantly, you boleh predict from kalau you ada stability curve, then you boleh predict. Okay, super saturation juga boleh buat melalui apa? Evaporation pun boleh. Maknanya not necessarily cooling, tapi dengan memanaskan dia. Macam mana tu? Confused pula. Panas kata dia dissolve lebih. So how? Cuba someone explain to me how the evaporation you can reach that super saturation. Saya petik nama lah. Ingatlah saya cakap je. Okay, saya petik nama lah. Kalau tak ada voluntary, I will just call any name. Ada voluntary tak? Macam mana by using evaporation, you can create that super saturation. Okay, cuba Nur Nabila, give a try. Saya petik nama je. Tu cakap kalau ada orang volunteer selamat lah. Tapi tak ada orang volunteer. Jadi saya akan petik nama. Unmute. Okay, what do you think?
Because evaporation will reduce the water or the solution. We evaporate, so when the water evaporate, so it form crystal. I think
Okay.
so.
Yeah, it's almost there. So basically, mungkin semua orang ni semua faham pun sebab tu tak ada soalan. So bila saya tanya macam ni, jawapan dia tu almost there lah. They're correct, but need to tweak a little bit and then get a very precise punya ni explanation. But it's there. It's true. Okay, it's true that when you have evaporation, okay, you belajar evaporation dalam unit operation kan. Let's say this is your vessel, you evaporate it. When you evaporate, let's say you ada water, so you remove H2O. So what happened? Now the volume is become decreasing. Okay, because solubility will also depends on the volume, right? Tadi di 1 liter. Just imagine kalau sekarang ni you ada 200 ml je. So yang akan soluble pun tak banyak, jadi sikit. So that's why bila you reduce dia punya water, so solubility pun akan impact. Okay, so that's why you also can reach the super saturation punya condition. Okay, thank you very much tadi yang jawab. Okay, super saturation by combine. Okay, ada juga yang buat combine. Cooling, evaporation. Cooling, evaporation. So lagi cepat lah. Maknanya you evaporate and then they cool. Dah jadi concentrated. Concentrated ni maknanya lagi banyak solute dalam little bit amount of liquid. Lepas tu dia cool down. Lagi cepat dia obtain di crystal. So this is the method lah how to reach the super saturation. So once you know the method, so you can now relate dengan type of crystallizer lah. Kenapa dia ada benda ni? Kenapa dia ada benda tu? Now you understand lah how. Kenapa I have to explain that first before I move on to this slide. Because later on you can relate why they have cooling and so on. Okay, like this one, dia ada pakai apa? Okay, you see that dia ada feed masuk. Okay, so dia akan go down, dia akan heat up. Dia akan panas. So dia ada kat sini dia ada evaporation lah. Dia ada heat up, so dia ada evaporation. So when they evaporate, some of them akan keluar ke atas. So kat sini akan jadi concentrate. So concentrate, when they reach equilibrium, then they start to take the product. Alright, and then they are doing the same and feed again and again. Because some of the product discharge, of course lah, dia akan ada some of the things that were coming. So to make them balance. Okay, 10 masuk, 10 keluar lah. Macam tu lah. And this one, you ada evaporation kat sini. Dia evaporate, so pergi atas. Sini pun concentrate. So dia tak ada cooling. Okay, dia ada crystal dan you cukup masa dia akan ambil produk. So this one pun sama juga. Cuma dia dalam bentuk vacuum. Okay, this one not vacuum. Kalau vacuum ni the advantage dia, the heat that you want to supply is not high compared to the one that without vacuum. Alright. This is the now we move on to this one, MEB, mass energy balance. Ni you need to listen carefully how to calculate. Okay, this is example solubility sodium thiosulfate example ada material, ada compound, dia ada their own punya solubility curve. So you can see that here, okay, most of the compound lebih kurang macam ni lah, dia depends pada dia punya structure nanti. So what happen is that kalau you tengok sini, this is temperature, this is solubility. Solubility bermaksud berapa banyak sodium thiosulfate boleh dissolve dalam 100 kilo of water. Okay, so as you increase the temperature, you nampak you increase temperature, solubility pun increase. Lagi banyak yang boleh soluble dalam 100 kilo of water. Okay, so at the same time, if you look here, okay, if you look here, the crystal type also change. Okay, kalau you operate your crystallizer, let's say you operate dekat sini 80 degree Celsius, so you're gonna obtain pure sodium thiosulfate. Right, so you're gonna obtain pure thiosulfate. And if you work at the 70 degree Celsius, so your crystal gonna be thiosulfate with half H2O, hydrate. H2O ni normally dipanggil hydrate lah. Okay, belakang tu half of hydrate molecule. Alright, if you move more to 60, you're gonna obtain thiosulfate with 2 hydrate. And then if you are at here, this region 40 and below or 50, so you have like sodium thiosulfate with pentahydrate. Pentahydrate meaning that you have 5 H2O lah. So dalam molecular weight, okay, sebab you need to know the molecular weight. Molecular weight ni, then you need to know to identify what is your crystal type. Okay, based on this solubility punya curve lah, you tahu kat mana. Right, this information you can get from here. Let's say you operate dekat 40 degree Celsius. So you know that the crystal type gonna be this thiosulfate with 5 pentahydrate. So in term of when you calculate molecular weight, you kena calculate sekali dengan 5 H2O tu sekali. Campurkan dalam, add on in the molecular weight. Boleh faham? Together. Kalau kata you operate at 90, let's say the crystallizer operate at 90 degree Celsius. It's very simple. Normally that is information. So you know that crystal yang akan form adalah 100% sodium thiosulfate, then okay lah, there's no water there. Okay, tak perlu tambah. Tapi bila you operate somewhere below that, you akan ada water attached together with that thiosulfate, that crystal. Boleh, saya tahu you all faham. Alright, so what happens is that for you to reach the solubility, to reach the crystal region, you need to have like something around here. Semua kena kat atas ni. Anything that above here, you're gonna obtain crystal. Okay, you're gonna obtain crystal. So, ni contoh Okay, ini kita dah pergi MEB. Okay, I think we just gonna stop until MEB ya, and then next week we're gonna continue with the crystal growth lah. So MEB for crystallizer. Okay, first you need to understand this is you punya crystallizer. Let's say this is your crystallizer. Okay, to do the MEB, you need to know that you have feed coming in, right? So then dia pergi ke crystallizer ni, dia adalah boleh pakai evaporation, boleh pakai cooling. It's up, it depends. When it turn to crystal, okay, you have to understand, not all the liquid will turn to crystal. Betul tak? Ke semua jadi crystal? Tak, you akan ada liquid. Okay, kita panggil dia mother liquor lah. Ataupun liquid yang after crystallizer, dia still dalam bentuk liquid, and you akan remove. Okay, you akan remove here crystal. Bila you remove crystal ni, ni yang you kena tahu dia punya molecular weight and crystal type. Ada H2O ke tak ada ke, then you kena tahu daripada stability punya ni lah, ataupun information yang they give you. Okay, dalam crystallization, remember that kita ada cooling, kita ada evaporation juga. So kalau kata ada yang menggunakan evaporation, if they are you are using crystallizer with evaporation, so you akan ada remove some water kat sini. Kalau ada evaporation. If they don't use evaporation, contoh they use only cooling, so this evaporation gonna be zero lah value dia nanti. Boleh faham? Okay, as for now, we take it as ada value. Okay, kita take it as you have like water evaporating. Ada soalan sebelum I move on to the calculation? Ni H2O. Yang atas ni confirm H2O sahaja, water sahaja akan remove, ataupun solvent lah, let's say. Normally dia akan pakai water lah. Crystallization ni dia solution is the water in dissolve in water. Question tak ada Okay, kalau tak ada, I move on to the how to make. Apa dia?
Mother liquor tu mix solid dengan solution ke?
No, kan saya cakap tadi. Okay, ni sebelum you buat crystallization, you ada liquid. Dalam liquid tu you ada solute yang dalam bentuk ion lah. Tak ada liquid lagi, tak ada solid lagi. So bila dia pergi crystallization, proses, then you akan start ada liquid and also crystal yang akan form. So what happen? You akan ambil crystal ni, and then atasnya ada liquid yang tak jadi crystal pun. So ni lah dia. This is the liquid yang the crystal is not formed. So basically dalam crystallization, kalau katalah you draw betul-betul, okay, this is the block diagram. So if you draw the equipment, let's say you draw equipment, maybe you akan ada like dia akan masuk ke dalam separator, you akan ada this is your crystallizer, and then ada separator, you akan obtain you punya crystal. Kat sini akan ada liquid yang keluar, macam tu lah, right? So the mother liquid is basically liquid that is the crystal is not forming after the crystallization. Boleh faham?
Boleh, Doktor.
So you separate kan, this is solid lah, crystal and also liquid. Alright, so you dah ada feed. Okay, feed ni I letak sebagai F lah, ke dia guna perkataan lain lah sini. Kalau dia solve ni dia guna apa sebab nak kena tally sikit supaya sama. crystal C, W, alright, and F. I think F and S. Alright. W, okay, S. Okay, this one kita panggil F, feed. This one kita panggil W lah. Biasanya water, stand for water that going out in the kalau ada evaporation. And mother liquor we call it S, solution lah. Solution that don't have any crystal. Crystal, this is a C. Okay, C. So from here you can do balance lah in. Okay, I kena buat kat bawah ni supaya you akan lebih jelas. Okay, before that, you need to know information of molecular weight. You need to know dissolubility. Here, you need to know maybe solubility pun boleh. You need to know the weight percent. Kalau ada weight percent pun boleh. Mana-mana information yang ada lah. Okay, they can be that. Alright. So this one is wajib. Compulsory to know the molecular weight of crystal. Okay, so now we do balance in equal to out. Mana yang in? In kat mana? Satu je kan? Dekat feed. Out ada 3. You have 3. W, S dengan C. But before that, kita kena buat balance fokus kepada component. Which component that you want to focus? Okay, kita ada apa? Water yang remove dengan crystal. Itu dah kita punya interest. Okay, so that the crystal akan remove from the water. So kita boleh buat balance. H2O balance. Okay, water balance. Okay, so nak buat water balance, kita buatlah feed, carilah weight percent untuk dapat water. Okay, time something lah kalau dia pakai weight percent. Kalau dia pakai solubility, then you need to know what is the solubility, and then you can get the water. Okay, weight percent of, kalau ni weight percent lah. F time weight percent of water, you get the mass of water. Alright. And then equal to which one you have water. Dekat W tadi lah. W ni, you ada water. Mother liquor pun you ada water. S is the punya stream. The mass flow rate of that stream. And then when you want to know the mass of water, so you need to know the solubility. Okay, solubility, what is the unit? Normally is katalah you have kilo of solute, kilo of crystal over kilo of water, kan? So to get this water here, you need to know mass of water. So mass of water apa sini? Kilo of water is basically water is 1 kilo lah kalau kat sini. Kalau unit ni solubility is divided by 1 kilo. So total solution is basically 1 kilo of water plus dengan X kilo of solute. Then you dapatlah apa ni water punya mass plus ni dekat solution ni crystal. Crystal times dengan molecular weight. So molecular weight apa? Water H2O, berapa H2O dia kalau dia ada H2O, divide by the total molecular weight. Maknanya dia punya crystal plus dengan H2O punya molecular weight. Okay, nanti kita tengok example, kita nak nampak lah dia punya ni. Okay, this you ada balance untuk water. And then you buat balance untuk crystal. Okay, crystal you ada F, weight percent of crystal, sama juga dengan W. W ni ada crystal tak? No, normally you don't have any crystal that going out as evaporating. Crystal tu memang kat bawah je. So dia akan jadi 0 lah W. Plus S, ni X kilo of solute over 1 kilo H2O plus X kilo of solute. Ini macam ni dapat crystal punya ni mass balance plus C molecular weight of crystal divided by molecular weight of crystal plus H2O yang you ada. So you ada dua equation. Equation 1, equation 2. You have to solve it simultaneously to get C ke S ke apa ke, depends lah. Okay, you have to solve it simultaneously to get the, normally they will ask how much crystal that you obtain, what is solubility, what is the feed maybe need to put it in the crystallizer. So depends lah. depends on the question. Okay, kita tengok example ni. Okay, let's say dia ada feed in 100 kilo of solution. Dia bagi 30% is sodium carbonate. Dia masuk dalam crystallizer. When they put in the crystallizer and the crystal is decahydrate. You need to take care of this. Decahydrate means you ada 10 H2O. This is the crystal punya molecular weight structure. Sodium carbonate dot H2O ni 10 H2O decahydrate. And you have solution that going out that not form crystal. So solubility dia adalah 21, dia bagi 21.5 kilo of sodium carbonate over 100 kilo of H2O. So W dia tak bagi. So do this, assume no water evaporated. No water evaporated meaning that this akan jadi kosong lah, nanti kita akan tengok ni. Okay, kita tengok yang A dulu. Lepas tu kita tengok yang B, assume you ada 3% yang remove sebagai water. Okay, macam mana nak buat balance? Tadilah kita ada F. Okay, kita buat balance dalam kes ni, kita buat water dulu. H2O. So F is 10,000. Water 30% adalah sodium carbonate. So another 70% adalah H2O lah. Right. So 0.7 equal to W plus S. S you tak tahu pun berapa banyak yang keluar unless dia bagi. The solubility is 31.5, 100 kilo. Ni kalau you nak check water, you tahu that water is what? 100 kilo kan? H2O. Over berapa total solution tu? You ada 100 kilo H2O plus 21.5. Inilah dia buat. 100 kilo plus 21.5. So 135 times S. Plus C. C crystal. Ni you kena tahu molecular weight. Okay. Molecular weight of H2O here 180. Sodium carbonate is 106. So now you buat balance pada water. Water is 180 lah. So 180 molecular weight divided by total of that crystal is 106 plus 180. So you dapatlah kat sini. W is 0 lah pasal no water evaporated. So this is equation 1. Okay, now you buat balance on crystal or sodium carbonate. So F is 10,000 times 0.3 equal to W. W probably 0 lah pasal tak ada pun evaporated plus S. Now what is the solute? 21.5 divided by 100 plus 21.5 solubility punya value kan. Okay, and then plus C crystal, molecular weight of sodium carbonate is 106. Total of that crystal is 106 plus 180. 106 is sodium carbonate, 180 is water sebab you ada 10 water. So you ada dua equation. So you solve it continuously, simultaneously, you boleh pakai calculator sekarang ni, dia boleh solve terus. So crystal is 63,000. Solution yang keluar tak ada crystal adalah 3,600. Okay. For part B, they mention that evaporation adalah 0.03. So you carilah W tu adalah 0.03 times 10,000. So 300 kilo keluar sebagai H2O. So you akan tukar dekat sini lah. Yang balance dekat H2O. Dekat crystal tak kacau langsung. Will not affect anything because there is no crystal that going evaporated. So you tukar balik, you tengok solve simultaneously, then you get now crystal 6,600. Solution is 3,000. I think there's something wrong here. Bukan 6,000 ni. Ini 6,000. Ni 6,300, 6,600. Ni betul. Ni salah belakang. So you see that when you evaporating some water, you can obtain more crystal. Ni dia punya impact lah. You nampak, you evaporate, you akan dapat more crystal. Soalan? So now it's 11:25. Soalan tak? Okay, kalau tak ada soalan, kita akan stop kat sini. Heat effect ni, we're gonna discuss it next week together with the crystal growth lah. Before that, yeah, please. Can be. mix dengan feed. Boleh? Boleh je. Okay, they can ask anything, even recycle, maknanya solubility tu masuk balik dalam you punya feed. Kalau let's say dekat feed tu dia tak bagi weight percent, but they give solubility, you gonna apply the same thing yang macam dekat solution tadi. You akan cari berapa mass of contohnya crystal over total mass of that solution. Solubility tu kan dia ada mass of solute over mass of water plus dengan solute. So dia akan manipulate kat situ lah kalau dia tak bagi weight percent. Sebab ada juga, they have also question that they not give a weight percent, but they rather than give you solubility value. But the thing is, you gonna use the same method lah. Same method je, tak ada method yang berlainan. Okay, so ada lagi soalan tak? Sebelum kita stop kita punya lecture. So then you gonna continue with your quiz. Okay, tak ada. Okay, I gonna stop this team.